We're now going to talk about some new ways to talk about sequences, and they'll allow us to say interesting things about how a sequence behaves. These are important definitions. Here's our first definition. A sequence, A sub n, is called increasing if A sub n is less than A sub n plus 1 for all n equals 1, 2, 3, 4, etc. What that means is each term is bigger than the previous term. Similarly, a sequence A sub n is called decreasing if A sub n is greater than A sub n plus 1 for all n equals 1, 2, 3, 4, etc. That means each term is smaller than the previous term. We call a sequence monotonic if it's either an increasing sequence or a decreasing sequence. Here's an example. If we look at the sequence 1, 2, 3, 4, etc., that's this. We can write that as the sequence n. That's the sequence whose nth term is n. This sequence is increasing. It's pretty obvious each term is bigger than the previous one. If we look at the sequence n minus 1 over n, we've looked at that one before. That's 0, 1/2, 2/3, 3/4, etc. This one's also increasing. If we look at the following sequence, 1 over n, that's 1, 1/2, 1/3, 1/4, etc. It's pretty clear that this sequence is decreasing, since each term is smaller than the previous term. There are many sequences which are neither increasing nor decreasing. This is the sequence we've looked at before, minus 1 to the nth power. This is neither. Neither increasing nor decreasing. All of these are monotonic, whereas this one is not monotonic. Sometimes you might have a sequence like this. 7, 0, 1, 2, 3. This sequence technically is not an increasing sequence because the second term is smaller than the first term. So this one is not increasing, it's certainly not decreasing, so this one is not monotonic. But there are other words we can use to describe sequences like this, such as eventually increasing. That just means beginning at a certain point, it's increasing from then on. Here's some more important definitions. We say a sequence is bounded above if there's some number n, m, such that a sub n is less than or equal to m for all n greater than or equal to 1. And similarly, we say the sequence is bounded below if there's some number m such that a sub n is greater than or equal to m for all n greater than or equal to 1. We call a sequence bounded if it's both bounded above and bounded below. Here's an example. This sequence n is not bounded above. Because it gets bigger and bigger and bigger. We actually use the term it gets bigger without bound. The terms increase, and if you pick any number m, eventually the terms get bigger than m. The sequence is bounded below. It's bounded below by the number 1. Every term is at least 1. So we actually use the term that 1 here is a lower bound. for the sequence. Here's a different sequence, 1 over 2 to the n. That's the sequence 1/2, 1/4, 1/8, etc. This sequence is bounded above and bounded below. What is an upper bound? An upper bound is a number which is greater than or equal to any term. Here, 1/2 is an upper bound. Notice we could have also said that 6 is an upper bound because every term in the sequence is less than or equal to 6. Try to think what a lower bound might be for this sequence. If you pick any positive number, these terms eventually will get smaller than that positive number, but we can say that 0 is a lower bound because every term is greater than or equal to 0. Of course, a number like -17 is also a lower bound because every term is greater than or equal to -17.